Hi guys. All right, so this one is continue from our earlier lecture about the cardiovascular system. So with the cardiovascular system, we talk about individual heart, cardio, and also we talk about the vessel. So we talk about those, and then we're gonna extend it into a very important concept and also a very clinical relevant issue, which is the blood pressure. So because a lot of us has hypertension. You kidding me? I don't have hypertension. Okay, that's good for you, but um, a third of American adults have hypertension. So like we are adults, a third of us has hypertension. So the question is, do you know your blood pressure? If you don't, go measure it. You can go to Walmart, it's free. You just go there and measure it. The thing about the hypertension is that it's not, you don't feel sickness. So you don't know. But over time, a chronic blood pressure, high blood pressure gonna damage your blood vessel. So earlier, you can manage it, and so you can prevent the disease caused by hypertension. So that's the important part. I think a third of us is pretty high. Adults like 20 years and older, so that's that's a big population. All right, so we are going to talk about this blood pressure. So what is blood pressure? Blood pressure basically is fluid pressure. This is the thing that we will do in the lab. Sphygmometry, or sphygmomanometer. It's a device that we will use to measure the blood pressure. But basically, blood pressure is the fluid pressure, the blood fluid pressure. Why is that pressure? Just like you watering, right? Agriculture, the watering, the plant, right? So you will have a hose and a faucet open up and then water coming out, right? So that water has a pressure. This pressure, of course, is highest from the source, right? I hope I didn't uh, from the source. Did I lose the connection? Man, did I? I hope not. All right. So the fluid has a pressure, and so the pressure. So you can see here is a fluid pressure. Here is the left atrium. So this one basically systemic circulation originate from the left ventricle. So when the heart contracts, the pressure squeeze it, so the pressure will be the highest because you reduce the volume, right? You reduce the space. So you squeeze it, so the pressure is highest. When you relax, uh, the ventricle relax, the pressure will be lowest. So in the heart, you have the entire range of that pressure change from the highest to the lowest to a zero. But when you squeeze it into the artery, because artery uh, when the artery will have the high pressure when it gets squeezed out, but when the heart dilate, relaxed, artery pressure still remain in the artery because they cannot flow back to the heart. So they always maintain a certain pressure. So that minimum pressure that artery will maintain. We call it diastolic pressure. So the pressure will vary between systolic and the diastolic. So this one is a systolic pressure and this one is diastolic pressure. And this one basically is the frequency of this one is basically is a heart cycle, right? So the higher heart pump, it will this oscillation will get narrower, and regularly you will have 60 beats per minute, so you're gonna have 60 changes in a minute. So that's that. We can get the blood pressure from the artery. We start to get the blood pressure from the artery. We have systolic, diastolic. This is important for systolic, indicate how strong the heart pump. For diastolic, because heart dilate, and this pressure will indicate how narrow the blood vessel is. If the blood vessel is more opening, then your diastolic will be lower. If the blood vessel is very narrowing, you don't give it a little more space for keeping those blood, then the blood pressure will be higher. So systolic blood pressure usually indicate more like heart related issue. Diastolic pressure usually indicate the vessel problem. So just give you some idea that why do we measure this. You can measure it from the aorta, but you all know that I can show the picture. Maybe I have the picture right here. Yeah, we all know that aorta here is aortic arch, ascending aorta, descending aorta. I suppose you guys know this. Why this is anatomy, right? If not, it's not that complicated. It's ascending and descending, right? So this is aorta. Aorta is very interior, so it's very difficult to measure. So what we measure is measure the brachial artery. So let me show you here. So this is the aorta. So our primary interest is the aorta because that is the artery to provide the systemic circulation, right? Systemic body organs to have the oxygenated blood. But we cannot measure it directly. We usually measure it the large aorta. So the like brachial artery. The large aorta, the closer you get into the heart is better, but the best we can do, the more practical way that we can do is measure the brachial artery. So you can see that it will give you very similar reading, similar like aortic artery. It's just a little bit higher because the blood vessel right here is narrower. So the narrower blood, the higher blood pressure you're gonna get. Yeah. So also over time, it will gradually drop. It's because that it's like waterfall, right? Water like river. So the further down the pressure, the speed of fluid will get slower. So you can see that pressure will get lower from the aorta to large artery. When it reaches to the capillary, it almost reached to almost like zero, very low. Yeah. So this is systemic that in the pulmonary, you go from the ventricle, right ventricle, and it give you the pressure. Pulmonary artery pressure is much, much lower. So this is because it's not very, the circuit is doesn't involve a lot of organ, right? You only go to the lung. So the pressure doesn't have to be so big. It's like you are watering a small area of your lawn, or you're gonna water the whole field for your agriculture, right? So it's the pressure will be different. If you only watering a small field of your garden, then you don't need that much of the blood pressure. So that's the situation right here. We only need to go to one organ that's a pulmonary lung, right? So that's that. So this is the blood pressure. What we really care the most is the aortic because that's systemic circulation. And we cannot measure aorta directly, we measure the large artery. So this one just show you that when we measure it, like here, you have the systolic, diastolic, the systolic, diastolic. We just expand these to see their change. You can see that here. So the blood pressure unit is mmHg. So this is the unit that you need to know that when people talk about like, what's your blood pressure? You have two numbers, systolic and diastolic. The higher one is systolic. Another one is diastolic. And the unit is mmHg. So you can get the blood pressure from the aorta here. I show you the blood pressure. You can use different method. In clinical, or in the bedside, we basically just measure brachial artery pressure. You can see that it's higher a little bit than the aortic artery, but we use this as a standard now. Yeah, carotid artery is also very important. The blood going to the brain. So carotid is to the brain. Coronary is to the heart. We have the quiz on this one. So if you mess it up, now you should know. Carotid is to the brain. And here is further down here, you go to a radial. Now you can see that because blood vessels become narrower, your blood pressure will gradually increase by that. But because it's further away from heart, it actually will gradually decrease. So these two forces are competing each other. So that's that. What we really care is the aorta. We call this one central blood pressure. There are two meanings for that. It's close to the central, the heart. It also is the origin of the systemic circulation. So it's important for our bodies. Oxygenation. Lack of the oxygen to any organ to our body is always a bad thing. Temporary low oxygen supply is okay. Like when you do exercise, your blood supply is limited because you use more than you can provide. So there will be a little bit hypoxia, like low oxygen supply. But that's good. You kind of like provide some stress to your muscle. Exercise basically is a stress. But we don't exercise like whole day, right? We exercise. What's more important is the recovery period. So you exercise, use your muscle, give it some stress, give your whole body some stress. Then you drink some more water, recovery. During that recovery, your organ will remodel, which will make it become stronger and growing, and yeah, stronger and bigger basically. And so you prepare your organ for future stress. So it's a training process. Yeah. But you don't want your organ to be chronic hypoxia, right? So this blood supply to the system is good. So what we really care is aortic central, but we cannot get it. So the next best thing we can get is bronchial artery. We don't do the carotid. It's not, I think it's probably doable. It's just, too many artery around. You have left and right carotid artery, but in the arm you only need to deal with either left arm or right arm, right? So that's easier that way. So this is what we do. We will measure the bronchial artery as a readout for your blood pressure. So just some device that we use. This is the device that we use. Basically, you will need a cuff, and your cuff will wrap around the bronchial artery. So this is bronchial artery. You wrap around it, and then you will pump it to increase the constraint or restraint constraint of this cuff. You flatten it, so it will narrow, it will compress the artery. So you will increase it pretty high. We can use manual pump, or nowadays we can use electronic. So basically, it do the same thing. It's just like how you pump your tire. You can do manual, or you can do just put a coin and then hit the button, then it automatic pump it. So we can do either way. So you can increase the cuff, increase the air in the cuff, it compress the artery. So compress to a level that you don't have blood flow go through. Okay, so just temporary is not going to kill you or anything. If we do the carotid, it will be bad. All right, so that's why we don't do the carotid. We cannot sustain any the person will faint. So don't do the carotid. Yeah, so it's bronchial. So when you close it, you also listen to the sound. So when you close it, there will be no flow. So nothing will go through, so you won't hear anything. And you gradually relieve it. So there is right here. So you can relieve it. So when you relieve it, air will gradually flow away, flow out. When you flow out, you gradually open it. When you open it to a level that blood can go through, you start to hear sound. And when you start to hear sound, the first sound you hear, and you look at the pressure that you can measure right here, this pressure gives you the systolic blood pressure. And you keep on relieving it, pressure will gradually drop because now cuff air pressure gradually drop. When you drop to a level that become wide open, when the artery become completely open, you won't hear any sound anymore because the fluid will go through smoothly, so you won't hear any turbulence or like a bouncing around of this fluid to the vessel wall. And by then, you won't hear anything. And the first time you don't hear anything, you look at the pressure, and what you read is the diastolic pressure. So from here, you can have systolic pressure and the diastolic pressure. So that's how we measure the blood pressure. What you really need to kind of like terminology wise, what you really need to know is bronchial artery, right? This is artery we use. What else? Let me see that here. Cough, that's easy. Stethoscope. So this is a device that we will use, stethoscope, to listen to the mechanical signal, right? The wave, basically sound wave, all right? You can use this to listen to the fluid. This fluid sound has a name right here. Korotkov, sorry about that, Korotkov sound. So Korotkov sound is a sound that indicate the time to read systolic and diastolic pressure. When the sound disappear, that's a diastolic pressure. And so what else? Yeah. So that's that. All right. So that's how we measure blood pressure. All right. So more important for every one of you is that you need to know your blood pressure. All right. In the lab, we're gonna measure the blood pressure. So if you didn't get a chance to measure blood pressure, use this opportunity to practice it. Yeah. Another thing about measuring blood pressure is that, all right, we will talk about the blood pressure. We probably, okay, I can say it. When you measure blood pressure, you want to make sure that you don't constrain your muscle, right? Just relax your arms and also relax your body, because the blood pressure is sensitive to two things. One is the heart to squeeze the blood. So but you don't change your heart as long as you become calm. If you're nervous, then your heart pump faster. But say you remain calm. But another thing is the basal wall. So you don't compress it. You don't want to like say you need to measure it and then you just uh, leave, right? Raise your like clothes, right? Something like that. You don't want to compress your artery or even vein when you measure it. So just relax. Don't cross your legs, because when you cross leg, you compress a lot of your vessel. So just relax and put your leg down, right? Something like that. And so that's how you do the measurement. So when we measure, this is what we measure. We can measure right here. So we can measure the systolic, diastolic, basically here. We can measure the systolic, diastolic. We can measure that. There are some additional measure we will get from these two measures. That's the same thing. It's the same measure. It's the same wave. It's just we have different reading from it. So we can, the very common term, when you measure it, you basically get two numbers. One is systolic, one is diastolic. From there, we will also sometimes try to measure two other things. One is called pulse pressure. Pulse. This is pulse, right? This is pulse. The pulse pressure is from the top to the bottom. So this is pulse pressure. It's a systolic minus diastolic pulse pressure. Another thing we will also try to measure is mean pressure. So mean pressure just give you one number. So what's your blood pressure? Say 140, 90, oh, two number, complicated. Which one are you talking about? Systolic, diastolic. Okay, that's all good. But what's your mean, like average? The mean blood pressure. Mean pressure is not in the center though, because we have more time in the diastolic. If you remember that our cardiac cycle, like the one we talked earlier, we have the action potential of the atrium, action potential of ventricle, and then resting, right? That T P QRST, T to the next P, that resting time is usually occupy a lot of time throughout the entire cardiac cycle. So we have more time in diastolic. And so your mean is tend to uh, uh, tend to be lower because you have more diastolic, right? So this is lower part. So that's the mean pressure. So you basically, the mean pressure, how do you get the mean pressure? You basically will get the pulse pressure, that's a difference right here, right? So you get a third of this. So this is like a third of here, right here. So you will get like diastolic plus a third of pulse pressure, something like that right here. Or diastolic plus the difference between systolic and diastolic. So that's the mean pressure. Should be easy to understand, right? So here is all these. I should bold this one too. Systolic, diastolic, pulse pressure is a difference. Mean arterial pressure, MAP, is diastolic plus a third of pulse pressure right here. So that's that. This one just give you the idea about the normal range. Normal range will be 120 over 80. All right, so that is normal range. Higher than that, you need to have a concern. Okay, it's very easy to get into this range, so don't feel embarrassed or feel like stress or something like that. It can be manageable. Okay, so the thing is that you need to know and to measure to manage it. Go to see a doctor. There are many different kind of like medicine. Some will work for you, some will not. So get the major first, so you have the idea. Yeah. All right. So that's the blood pressure. Um, let's take a break, and then we will look into the next thing, which is the theory of the blood pressure. We will talk about this equation. Okay.